Welcome to the online lesson on the Geography of Turkey 1, Physical Geography of Turkey course. In today's session, we will delve into the hydrographic features of Turkey's river. The rivers in Turkey exhibit a variety of characteristics, reflecting the diverse geography and climatic conditions of the country. Here are some general characteristics of rivers in Turkey. Number 1. Geographical diversity. Turkey's rivers flow through diverse landscapes, including mountainous regions, plateaus, and plains, contributing to the varied topography of the country. Number 2. Abundant river systems. Turkey is crisscrossed by numerous rivers, both large and small, creating an extensive river network that plays a crucial role in the country's hydrology. Number 3. Climatic influence. The distribution and flow of rivers are influenced by Turkey's climatic zones, ranging from Mediterranean and Aegean climates to continental and steppe climates in different regions. Number 4. Agricultural importance. Many rivers in Turkey serve as vital water sources for agriculture, supporting irrigation systems and contributing to the productivity of fertile plains. Number 5. Hydroelectric potential. Several rivers are harnessed for hydroelectric power generation, contributing significantly to Turkey's energy production. Number 6. Historical significance. Some rivers hold historical importance, with civilizations and ancient cities often established along their banks. Rivers like the Tigris and Euphrates have played significant roles in the history of the region. Number 7. Biodiversity. River ecosystems in Turkey support diverse flora and fauna, contributing to the country's biodiversity. These rivers provide habitats for various aquatic species. Number 8. Touristic appeal. Scenic river valleys and landscapes attract tourists, offering opportunities for outdoor activities such as rafting, fishing, and trekking along riverbanks. Number 9. Transboundary rivers. Turkey shares several rivers with neighboring countries, such as the Tigris and Euphrates with Iraq and the Aras with Armenia. Number 10. Water management challenges. Water scarcity and management issues, especially in the arid and semi-arid regions, pose challenges for sustainable water use and resource conservation. Number 11. Dam construction. Dams and reservoirs are constructed on many rivers for multiple purposes, including irrigation, flood control, and hydropower generation. Number 12. Environmental concerns. Dam construction and altered flow regimes can have environmental impacts, affecting river ecosystems, sediment transport, and downstream habitats. Number 13. River protection efforts. Conservation initiatives and river protection projects are underway to preserve the ecological integrity of rivers and their surrounding environments. Number 14. Water quality challenges. Urbanization, industrial activities, and agriculture contribute to water quality challenges in some rivers, necessitating water management strategies. A river basin, also known as a watershed or catchment area, is a geographical area drained by a network of rivers and their tributaries. It is a natural hydrological unit where all the surface water drains to a common outlet, such as a river mouth, lake, or ocean. Here are key characteristics and components of a river basin. Number 1. Drainage network. A river basin is defined by the interconnected system of rivers, streams, and creeks that ultimately drain into a common water body. Number 2. Boundaries. The boundaries of a river basin are typically defined by natural topographical features such as mountain ridges or elevated areas. These boundaries determine the area from which water drains into the river system. Number 3. Topography. The topography of a river basin influences the flow of water. Mountains, hills, valleys, and plains within the basin contribute to the direction and speed of river flow. Number 4. Drainage divide. A drainage divide, also known as a watershed divide, separates one river basin from another. It is the elevated terrain that determines the direction of water flow. Number 5. Main river and tributaries. The main river, often referred to as the trunk stream, is the primary watercourse within the basin. Tributaries are smaller rivers or streams that feed into the main river. Number 6. Hydrological cycle. The hydrological cycle, including processes such as evaporation, precipitation, and runoff, plays a crucial role in the movement of water within a river basin. Number 7. Land use and human activities. Human activities within a river basin, such as agriculture, urban development, and industrial activities, can significantly impact the hydrology and ecology of the area. Number 8. Ecological importance. River basins support diverse ecosystems, including aquatic habitats, wetlands, and riparian zones. These ecosystems provide essential services and biodiversity. Number 9. Water management. Effective water management within a river basin involves balancing the needs of various users, including agriculture, industry, and municipalities, while considering environmental sustainability. Number 10. Flood control. River basins are prone to flooding during periods of heavy rainfall or snowmelt. Flood control measures, such as dams and levees, are often implemented to manage and mitigate flood risks. Number 11. Transboundary river basins. Some river basins cross international borders, leading to shared management challenges and the need for international cooperation. Number 12. Climate variability. Climate patterns within a river basin influence precipitation, evaporation rates, and overall water availability. Number 13. Water quality. Water quality within a river basin is influenced by land use, pollution sources, and natural factors. Monitoring and conservation efforts are crucial for maintaining water quality. Open basin. The term open basin is less common and not a standard term in hydrology. In a general sense, an open basin might refer to a basin that has an outlet where water flows out to the ocean or sea. However, it's crucial to note that this term may not be widely used or recognized in scientific literature. In a closed basin, water does not flow out to the ocean or sea but instead remains within the basin. It typically forms an internal drainage system where water collects in a lake or a salt flat, and there is no outlet to the ocean. The Great Basin in the United States is an example of a closed basin. In the case of Turkey, where two peninsulas, the Anatolian Peninsula and the Thrace Peninsula, and mountain ranges generally run parallel to the coastline, the geographical features can indeed influence the length and characteristics of rivers. Here's a more detailed explanation. 1. Mountainous terrain. Turkey is characterized by mountainous terrain, with the Taurus Mountains in southern Turkey and the Pontic Mountains in the north. These mountain ranges often have rivers originating within them. 2. Parallel alignment to coastline. The alignment of the mountains parallel to the coastline can result in relatively shorter river courses. Rivers originating in the mountains may flow relatively directly to the coast rather than taking longer, meandering paths. 3. Shorter river courses. The combination of mountainous topography and parallel mountain alignment to the coastline can lead to shorter river lengths. Rivers may have a more direct path from their source in the mountains to the sea. 4. Geographical constraints. The presence of two peninsulas, coupled with the parallel mountain ranges, creates geographical constraints that influence the overall flow patterns of rivers. This can contribute to the relatively shorter length of rivers in the region. 5. Hydrographic characteristics. The hydrographic characteristics, including the drainage patterns, are shaped by these geographical features. Rivers may exhibit a dendritic pattern with shorter, direct courses to the coast. Understanding these geographical features helps explain why rivers in Turkey, influenced by the presence of two peninsulas and parallel mountain ranges, tend to have shorter courses compared to rivers in regions with different topographical characteristics. An association between the elongation of rivers and the geological processes involving the stretching or extension of mountainous regions in Turkey. This connection is influenced by tectonic and geological factors. Here's an explanation specific to Turkey. 1. Tectonic setting. Turkey is located at the convergence of several tectonic plates, including the Eurasian Plate, the Arabian Plate, and the African Plate. The complex interactions between these plates give rise to various geological features. 2. Mountain ranges. Turkey is characterized by several mountain ranges, including the Taurus Mountains in the south and the Pontic Mountains in the north. These mountains have been influenced by tectonic processes, including compression and extension. 3. Extensional forces. In regions where extensional forces are prevalent, such as areas experiencing crustal stretching or extension, river valleys can form. The stretching of the Earth's crust can lead to the development of rift valleys or elongated mountain ranges. 4. Rift valleys and river courses. If the stretching of the mountains is associated with the formation of rift valleys, rivers may follow these elongated depressions. The lengthening of rivers in Turkey could be linked to the extensional tectonic forces shaping the landscape. 5. Geological time scale. It's important to note that geological processes occur over extended time scales. The lengthening of rivers due to the stretching of mountains is a gradual and long-term phenomenon that unfolds over millions of years. 6. Example, East Anatolian Fault. The East Anatolian Fault, which runs across eastern Turkey, is an example of a tectonic feature associated with crustal extension. This fault system reflects the interaction between the Anatolian Plate and the Arabian Plate. In summary, the lengthening of rivers in Turkey can be influenced by tectonic processes, including the stretching or extension of mountainous regions. The geological history and tectonic activity in the region contribute to the development and evolution of river courses over geological time scales. The geomorphology of rivers in Turkey is influenced by the quaternary epirogenetic movements in the Anatolian region. Let's break down the key elements. 1. Quaternary epirogenesis. The Quaternary period is the most recent geological period, spanning approximately the last 2.6 million years to the present. Epirogenesis refers to the vertical movements of the Earth's crust that result in regional uplift or subsidence over long periods. 2. Anatolian region. The Anatolian region, where Turkey is located, has been subject to complex tectonic activity due to the interaction of the Anatolian Plate, the Eurasian Plate, and the African Plate. This interaction has led to various geological phenomena. 3. Rivers and geomorphology. The geomorphology of a region, including the profiles of rivers, is shaped by tectonic processes. Epirogenetic movements, which involve vertical displacement of large crustal blocks, can affect the base level of rivers and influence their profiles. 4. Balance profile. The term balance profile typically refers to the equilibrium profile of a river, which is the idealized shape a river achieves over time, balancing erosion and sedimentation. Factors such as base level changes, tectonic activity, and climate can influence whether a river achieves this balance. 5. Impact on river profiles. The quaternary epirogenetic movements in the Anatolian region may have disrupted the attainment of a stable or balanced profile by rivers. Changes in elevation, tectonic uplift, or subsidence can alter the base levels of rivers, affecting their erosional and depositional processes. 6. Long-term geological processes. Geological processes operate on a long-term scale, and the impact of epirogenesis on river profiles is part of the dynamic evolution of landscapes over geological time. In summary, the statement suggests that the rivers in Turkey may not achieve a balanced profile due to the ongoing quaternary epirogenetic movements in the Anatolian region. This highlights the intricate relationship between tectonic processes and the geomorphological features of river systems in the context of Turkey's geological history. There is a relationship between the topography of Turkey and the hydrological characteristics of its rivers. Let's break down the key points. 1. Rugged and mountainous terrain. Turkey is characterized by rugged and mountainous terrain, including notable mountain ranges such as the Taurus Mountains and the Pontic Mountains. 2. High bed slopes. The rugged topography contributes to high bed slopes in rivers. Bed slope refers to the steepness or gradient of the riverbed. In mountainous regions, rivers often flow rapidly downhill, leading to steeper bed slopes. 3. High flow rates. The combination of steep terrain and gravitational forces results in high flow rates in Turkish rivers. The water moves swiftly down the slopes, contributing to increased flow rates. 4. Erosive forces. The steep slopes and fast-flowing water in mountainous regions contribute to more erosive forces. Rivers in such environments can transport larger amounts of sediment and shape the landscape through erosion. 5. Hydroelectric potential. While high bed slopes and flow rates can pose challenges for navigation, they are advantageous for hydropower generation. The potential energy created by the rapid flow of water in mountainous rivers makes them suitable for the development of hydroelectric power projects. 6. Natural features and challenges. The natural features of rugged and high terrain result in dynamic river systems with unique challenges and opportunities. The steep slopes create conditions for the efficient transport of water, sediment, and energy. In summary, the topography of Turkey, characterized by rugged and mountainous landscapes, directly influences the hydrological characteristics of its rivers. The high bed slopes and flow rates are a consequence of the country's geographical features, presenting both challenges and opportunities for various uses, including hydropower generation. Key factors influencing the hydroelectric potential of a rugged and mountainous terrain contributes to high hydroelectric energy potential. 1. Elevation and potential energy. Rugged and mountainous terrain often means significant variations in elevation. Water naturally flows from higher elevations to lower elevations, and this difference in elevation creates potential energy in the form of gravitational potential energy. 2. River flow and rapids. The presence of rugged landscapes often results in fast-flowing rivers and streams, with rapids and waterfalls. These features provide ideal conditions for harnessing the kinetic energy of flowing water. 3. Hydropower generation. Hydropower, or hydroelectric power, is generated by converting the energy of flowing water into electricity. This process involves capturing the kinetic energy of moving water and converting it into mechanical energy, which is then used to generate electricity. 4. Dams and reservoirs. In mountainous regions, the construction of dams and reservoirs can further enhance the potential for hydroelectric power generation. Dams regulate the flow of water, allowing for controlled release and efficient utilization of the water's energy. 5. Turkey's topography. Turkey is characterized by rugged and mountainous terrain, especially in regions such as the Taurus Mountains and the Pontic Mountains. This topography provides numerous opportunities for the development of hydroelectric power projects. 6. Diverse river systems. Turkey has diverse river systems with high flow rates, making it well suited for the establishment of hydroelectric power plants. Notable rivers include the Euphrates, Tigris, Sakarya, and others. 7. Renewable energy source. Hydroelectric power is a renewable energy source that produces electricity without greenhouse gas emissions. It contributes to Turkey's efforts to diversify its energy mix and reduce dependence on non-renewable sources. 8. National energy strategy. Turkey has recognized the high hydroelectric potential within its rugged topography and has included the development of hydroelectric power in its national energy strategy to meet growing energy demand. In summary, the rugged and mountainous terrain of Turkey creates favorable conditions for high hydroelectric energy potential. This valuable renewable energy resource plays a significant role in Turkey's efforts to meet its energy needs sustainably and reduce reliance on fossil fuels. The relationship between the topography of rivers, dam construction, and transportation in Turkey. Let's examine each point. 1. Rivers flowing in narrow and deep valleys. The description of rivers flowing in narrow and deep valleys indicates a specific topography where the river channels are confined by steep and elevated terrain. This type of terrain is common in mountainous regions. 2. Consequence, dam construction becomes easier. Narrow and deep valleys provide natural conditions that are conducive to dam construction. Constructing dams in such valleys is often easier because the steep and confined terrain facilitates the containment of water. Dams built in these locations can efficiently store water for various purposes, including hydroelectric power generation, irrigation, and water supply. 3. Consequence, positive impact on north-south transportation. The reference to rivers flowing in narrow and deep valleys can positively affect north-south transportation. In mountainous regions, river valleys often serve as natural transportation corridors. Roads and highways may follow these valleys, providing relatively easier routes for north-south transportation compared to traversing the rugged mountainous terrain. 4. Transportation corridors along river valleys. River valleys can serve as important transportation corridors, offering routes with gentler slopes compared to the surrounding mountains. Roads and infrastructure along these valleys facilitate smoother transportation, connecting regions in the north to those in the south. 5. Integration of infrastructure. The integration of dam construction and transportation infrastructure along river valleys demonstrates a holistic approach to utilizing natural features for both water management and transportation needs. 6. Hydroelectric power generation. In addition to easing dam construction, the presence of rivers in narrow and deep valleys is advantageous for hydroelectric power generation. Dams in such locations can efficiently harness the potential energy of flowing water. In summary, the specific topography of narrow and deep valleys in Turkey's mountainous regions offers benefits for both dam construction and transportation. This integrated approach reflects the utilization of natural features to meet water management and transportation requirements in the country. How the topography and hydrological characteristics of rivers in Turkey can affect their suitability for transportation. Let's break down the key points. 1. Rugged and mountainous terrain. Turkey is characterized by rugged and mountainous terrain, including the Taurus Mountains and the Pontic Mountains. This topography results in steep slopes and challenging landscapes for river navigation. 2. High bed slopes. The reference to high bed slopes implies that the rivers in Turkey have steep gradients or inclinations. High bed slopes can lead to faster water flow, turbulent currents, and increased erosive forces, making navigation difficult. 3. High flow rates. The mention of high flow rates suggests that Turkish rivers experience significant water discharge. While high flow rates can be advantageous for certain purposes, such as hydropower generation, they can pose challenges for transportation due to swift currents and turbulence. 4. Consequence: unsuitability for transportation. The combination of rugged terrain, high bed slopes, and fast-flowing rivers makes navigation challenging. Rivers with steep gradients and turbulent flow are less conducive to safe and efficient transportation, especially for vessels that may struggle to navigate such conditions. 5. Hydroelectric potential. While challenging for transportation, the rugged and mountainous characteristics of Turkish rivers contribute to the country's significant hydroelectric potential. Dams built in such environments can harness the energy of fast-flowing water for electricity generation. 6. Alternative transportation routes. Due to the limitations posed by the characteristics of Turkish rivers, alternative transportation routes such as roads and highways are often developed to connect regions in the country. These routes may follow valleys and offer more manageable gradients for transportation. In summary, the rugged and mountainous nature of Turkey's terrain, along with high bed slopes and flow rates in its rivers, presents challenges for river navigation. This has led to the development of alternative transportation infrastructure to overcome the limitations posed by the natural characteristics of Turkish rivers. The rivers in Turkey. 1. Carrying a lot of silt, severe erosion. Turkish rivers carry a substantial amount of sediment or silt. This sediment is often derived from erosion processes in the river's watershed, including weathering of rocks and soils. High sediment load is a characteristic of rivers with significant erosive forces. 2. Consequence: delta formation. Deltas are landforms that form at the mouths of rivers where they meet a body of water, typically the sea or an ocean. The deposition of sediment carried by the river results in the gradual building up of land, creating a fan-shaped delta. The abundance of silt carried by Turkish rivers contributes to the formation of deltas at their outlets. 3. Less effective tides and currents on coasts. The mention of tides and currents having less effect on the coast suggests that the sediment-laden rivers influence the coastal dynamics. Deltas act as natural barriers that mitigate the impact of tides and currents, helping to trap and deposit sediment near the river mouth. 4. Delta characteristics. Deltas serve as dynamic and ecologically important environments. They are characterized by distributary channels, wetlands, and sediment deposition, creating habitats for various plant and animal species. The specific characteristics of Turkish deltas would depend on the individual river systems. 5. Human and ecological importance. Deltas in Turkey, formed by the interaction of rivers and the sea, are often areas of ecological significance. They can also be important for human activities, such as agriculture, as the deposited sediment enriches the soil in these areas. In summary, the formation of deltas at the mouths of Turkish rivers is influenced by the substantial amount of silt carried by these rivers, indicating a high level of erosive activity. The presence of deltas helps buffer the coasts against the effects of tides and currents, shaping unique and valuable ecosystems in the coastal regions of Turkey. The Sora River, one of the fastest flowing rivers in the world, is famous highlights the country's natural assets and potential for water-based recreational activities. Let's explore the key points. 1. Significant potential for water sports. Turkey is recognized as having substantial potential for water sports, including popular activities such as rafting, canoeing, and water skiing. This potential is likely due to the diverse and dynamic river systems, lakes, and coastal areas across the country. 2. Sora River as a highlight. The mention of the Sora River emphasizes its significance in the context of water sports. The Sora River is renowned for being one of the fastest flowing rivers globally, making it an attractive destination for adventurous water activities. 3. Rafting and canoeing opportunities. The fast-flowing nature of rivers like the Sora provides ideal conditions for rafting and canoeing enthusiasts. Rapids and challenging sections of the river make it an exciting and adrenaline-filled experience for those seeking adventure. 4. Water skiing potential. In addition to river-based activities, the statement suggests that Turkey has potential for water skiing. This could be related to the presence of suitable water bodies, such as lakes or coastal areas, where water skiing can be enjoyed. 5. Tourism and recreation. The availability of diverse water sports activities contributes to the tourism and recreation sectors. Regions with suitable natural features become popular destinations for both domestic and international tourists seeking water-based adventures. 6. Natural beauty and adventure tourism. Turkey's rivers, lakes, and coastal areas not only provide opportunities for water sports but also showcase the natural beauty of the country. Adventure tourism, including water sports, contributes to the overall appeal of these regions. 7. Economic impact. The popularity of water sports can have a positive economic impact on local communities, supporting tourism-related businesses, accommodation, and recreational services. In summary, Turkey's significant potential for water sports, particularly rafting, canoeing, and water skiing, is underscored by the mention of the Sora River as a famous and fast-flowing destination. This combination of natural assets and adventure opportunities contributes to the appeal of Turkey as a destination for water-based recreational activities. Flow rate of most of the rivers in Turkey is low when compared to the European rivers. The reasons of this fact is: 1. Low rainfall in Turkey. The statement highlights that Turkey is a country with little rainfall. Insufficient precipitation can have a direct impact on the water availability in rivers, as the primary source of water for rivers is rainfall that contributes to streamflow. 2. Limited water input. In regions with low rainfall, rivers receive less water input from precipitation. This limited water input affects the overall flow of rivers, resulting in smaller volumes of water moving through the river channels. 3. Influence on river flow. The flow of rivers is closely tied to the balance between water inputs, such as rainfall, and outputs, such as evaporation and discharge. When there is limited rainfall, the natural replenishment of river water is restricted, leading to lower river flows. 4. Seasonal variability. The impact of low rainfall on river flow is often more pronounced during periods of drought or low precipitation. Seasonal variability in rainfall patterns can further contribute to fluctuations in river flow. 5. Implications for water resources. The availability of water in rivers is crucial for various purposes, including agriculture, industry, and domestic use. Insufficient river flow due to low rainfall can pose challenges for water resource management. 6. Water scarcity concerns. In regions with consistently low rainfall, water scarcity concerns may arise, affecting not only river flows but also overall water availability for ecosystems and human activities. 7. Alternative water sources. In response to low rainfall and reduced river flows, regions may explore alternative water sources, such as groundwater extraction or water storage through reservoirs, to meet water demand. In summary, the statement correctly attributes the small amount of water flow in Turkish rivers to the country's limited rainfall. Understanding the relationship between precipitation patterns and river flow is crucial for water resource management and addressing potential challenges associated with water scarcity. The irregularity of rainfall regimes in arid and semi-arid climates significantly impacts the flow rate of rivers in Turkey. Here's a breakdown of the key points. 1. Arid and semi-arid climates. Turkey, particularly in certain regions, experiences arid and semi-arid climates. These climates are characterized by low annual precipitation and high evaporation rates. 2. Irregular rainfall regimes. Irregularity in rainfall refers to the inconsistency and variability of precipitation patterns over time. In arid and semi-arid climates, rainfall may be infrequent and sporadic, leading to periods of drought interspersed with occasional heavy rainfall events. 3. Impact on river flow. The irregularity of rainfall directly influences river flow. In periods of low or no rainfall, rivers receive limited water input, resulting in reduced flow rates. Conversely, during intense rainfall events, there can be a sudden surge in river flow. 4. Seasonal fluctuations. Arid and semi-arid climates often exhibit distinct seasons with varying levels of precipitation. This seasonal variability further contributes to fluctuations in river flow, with peak flows during rainy seasons and reduced flows during dry periods. 5. Water scarcity and drought. Irregular rainfall exacerbates water scarcity issues, leading to drought conditions during prolonged dry spells. Insufficient river flow affects water availability for ecosystems, agriculture, and human consumption. 6. Challenges for water management. Managing water resources in regions with irregular rainfall becomes challenging. Water managers need to adapt strategies to cope with variability, including the development of storage facilities, efficient irrigation practices, and sustainable water use policies. 7. Environmental and ecological impacts. Fluctuations in river flow impact the environment and ecosystems. Aquatic habitats, flora, and fauna are influenced by changes in water availability, affecting biodiversity and ecological balance. Understanding the irregular nature of rainfall in arid and semi-arid climates is crucial for sustainable water resource management in Turkey. It involves implementing measures to cope with water variability, ensuring resilience in the face of drought, and promoting responsible water use practices. The period with the highest flows in Turkey, particularly during spring and early summer, is influenced by the melting of snow and the effectiveness of precipitation. Here's a breakdown of the key points. 1. Snowmelt. In certain regions of Turkey, especially in mountainous areas, snow accumulates during the winter months. The arrival of spring and early summer brings warmer temperatures, leading to the gradual melting of snowpacks. 2. Spring precipitation. Spring is a season when precipitation becomes more active. Rainfall in addition to the melting snow contributes to increased water input into rivers. The combination of snowmelt and precipitation enhances the overall flow of rivers. 3. Snowmelt timing. The timing of snowmelt is crucial. If snowmelt coincides with increased spring precipitation, the additive effect can lead to a surge in river flows. This is particularly important for regions where snow accumulation is a significant contributor to river flow. 4. Contribution to river flow. Snowmelt is a natural water storage mechanism. As snow accumulates during winter, it serves as a reservoir of water. When temperatures rise in spring and early summer, the gradual release of this stored water contributes to higher river flows. 5. Hydrological spring peak. The combination of snowmelt and spring precipitation often results in a hydrological peak, where rivers experience their highest flows during this period. This peak flow is important for sustaining river ecosystems and providing water resources for various uses. 6. Agricultural and ecological impact. The spring and early summer peak flows have significant implications for agriculture, as they coincide with the growing season. These flows also contribute to the ecological health of rivers and surrounding habitats. 7. Water resource planning. Understanding the timing and factors influencing peak flows is essential for water resource planning. It allows for the effective management of water resources, especially in regions where the availability of water is seasonally variable. In summary, the period with the highest river flows in spring and early summer in Turkey is a result of the combined effects of snowmelt and increased precipitation during this season. This hydrological dynamic is important for various aspects of water resource management and ecosystem sustainability. Turkey has several rivers that flow into the Black Sea. Here are some of the major rivers that contribute to the Black Sea drainage basin in Turkey. 1. Kızılırmak River, Elise. Originating in eastern Anatolia, the Kızılırmak River is one of the longest rivers in Turkey. It flows northward, passing through central Anatolia and eventually reaching the Black Sea. 2. Yeşilırmak River. The Yeşilırmak River, also known as the Iris, originates in the eastern Anatolian plateau and flows northward, draining into the Black Sea. 3. Sakarya River. The Sakarya River has its source in the eastern Anatolian plateau and flows northwards through central Anatolia, reaching the Black Sea. 4. Sora River. The Sora River is known for its fast-flowing waters and originates in the northeastern part of Turkey. It flows in a northeast direction and empties into the Black Sea. 5. Bartın River. The Bartın River has its source in the Kura Mountains and flows northward, discharging into the Black Sea near the town of Bartın. 6. Filios River. The Filios River, located in the Zonguldak province, flows northward and enters the Black Sea near the town of Filios. 7. Gökırmak River. Originating in the northern Anatolian mountains, the Gökırmak River flows northward and reaches the Black Sea. These rivers, among others, contribute to the diverse hydrology of the Black Sea region in Turkey. They play a crucial role in the ecological balance of the region and have been historically significant for transportation, agriculture, and other human activities. Certainly, here are more details about some of the rivers that flow into the Aegean Sea in Turkey. 1. Büyük Menderes River, meander, one of the longest rivers in Turkey. It originates in the Anatolian highlands and flows through the Aegean region, eventually emptying into the Aegean Sea near the city of Didim. The Büyük Menderes Delta is an important wetland area. 2. Gediz River, originating in the Murat Mountains, the Gediz River flows westward through the Aegean region, passing through cities such as Kütahya and Manisa. It plays a crucial role in the irrigation of agricultural lands before reaching the Aegean Sea. 3. Bakersay River, flowing through the provinces of Boxer and Izmir, the Bakersay River has its source in the Kaz Mountains. It meets the Aegean Sea near the ancient city of Alaya, modern-day Urla. The river basin is known for its historical and archaeological significance. 4. Küçük Menderes River, also known as the Little Meander, this river flows through the Aegean region and is an important watercourse for the surrounding agricultural areas. It meets the Aegean Sea near the city of Izmir. 5. Nilüfer River, originating in the Uludağ mountain range, the Nilüfer River flows through the city of Bursa and eventually reaches the Sea of Marmara. While not directly flowing into the Aegean Sea, it is a significant river in the western part of Turkey. 6. Manyas River, this river connects Lake Manyas to the Sea of Marmara. Lake Manyas is an important bird sanctuary, and the river contributes to the ecological balance of the region. These rivers collectively form intricate delta systems and contribute to the fertile plains and ecosystems in the Aegean region of Turkey. They have historical significance and continue to play a crucial role in the livelihoods of the people living along their banks. Several rivers in Turkey flow into the Mediterranean Sea. Here are some of the notable ones. 1. Ceyhan River, originating in the eastern Anatolia region, the Ceyhan River flows southward through the Çukurova Plain and meets the Mediterranean Sea near the city of Adana. 2. Ceyhan River, also originating in eastern Anatolia, the Ceyhan River flows in a generally southward direction, passing through the Adana Plain, and empties into the Mediterranean Sea near the town of Karatas. 3. Orontes River, a sea river, although not entirely within Turkish borders, the Orontes River rises in the Bekaa Valley of Lebanon, flows through Syria, and finally enters the Mediterranean Sea near the city of Samandag in the Hatay province of Turkey. These rivers contribute to the drainage of the southern regions of Turkey and play a significant role in the hydrology and ecology of the Mediterranean coastal areas. Turkey does not have rivers that flow directly into the Persian Gulf or the Indian Ocean. However, the Tigris and Euphrates rivers, which originate in Turkey, eventually merge and flow through Iraq, ultimately reaching the Persian Gulf. Here are details about these rivers. 1. Tigris River. Origin: the Tigris River has its headwaters in the Taurus Mountains in southeastern Turkey. Flow: it flows southeast through Iraq, merging with the Euphrates River before reaching the Persian Gulf. Length: the total length of the Tigris is approximately 1,850 kilometers. 2. Euphrates River. Origin: the Euphrates River also originates in eastern Turkey, near Lake Van. Flow: it flows southeastward through Turkey, Syria, and Iraq. In Iraq, it joins the Tigris River to form the Shatt al-Arab, which then flows into the Persian Gulf. Length: the Euphrates River is approximately 2,800 kilometers long. While the Tigris and Euphrates rivers have their sources in Turkey, their ultimate discharge into the Persian Gulf occurs in Iraq. Turkey is not directly connected to the Indian Ocean through its river systems. Its rivers primarily drain into the Mediterranean, Aegean, and Black Seas. The Kura and Aras rivers have their headwaters outside of Turkey but flow along the borders of the country. Here are details about these rivers. 1. Kura River. Origin: the Kura River originates in Turkey, near the border with Georgia. Flow: it flows eastward through Georgia, Azerbaijan, and eventually reaches the Caspian Sea. Significance: the Kura River is important for the countries it traverses, providing water resources for agriculture and supporting ecosystems along its course. 2. Aras River. Origin: the Aras River also has its source in Turkey, near the border with Armenia. Flow: it flows eastward, forming part of the border between Turkey and Armenia, and then the border between Armenia and Azerbaijan, before continuing through Azerbaijan and eventually reaching the Kura River. Significance: the Aras River has historical and geopolitical significance as it forms part of the borders between these countries. It plays a crucial role in the water resources and regional dynamics of the South Caucasus. While both rivers originate in Turkey, their significant stretches are outside the country's borders. They are important international rivers, impacting the regions they traverse and serving as vital water resources for the countries in the South Caucasus. Turkey has several river watersheds, each characterized by rivers and their tributaries that drain into a particular body of water. Here are some of the major river watersheds in Turkey. 1. Black Sea Watershed. Rivers: Yeşilırmak, Kızılırmak, Sakarya, Filios, Sora, and others. These rivers flow northward into the Black Sea. 2. Aegean Sea Watershed. Rivers: Gediz, Büyük Menderes, Bakırçay, Gediz, Büyük Menderes, Gediz, Büyük Menderes, Bakırçay, Küçük Menderes, and others. These rivers flow westward into the Aegean Sea. 3. Mediterranean Sea Watershed. Rivers: Seyhan, Ceyhan, Göksu, Dalaman, Köprüçay, Manavgat, and others. These rivers flow southward into the Mediterranean Sea. 4. Sea of Marmara Watershed. Rivers: Susaraluk, Biga, Aegean, and others. These rivers drain into the Sea of Marmara. 5. Internal watersheds. Central Anatolia, rivers like Kızılırmak and Sakarya have internal drainage, flowing into closed basins without reaching the seas. Lakes like Van, Tuz, and Bayzihir are part of internal watersheds. 6. Eastern Anatolia Watershed. Rivers: Euphrates, Frat, and Tigris, Dikil. These rivers flow southeastward, eventually reaching the Persian Gulf. These watersheds play a crucial role in the distribution of water resources, ecosystems, and agricultural activities across Turkey. The rivers within each watershed contribute to the unique characteristics of the regions they traverse. Certainly, let's expand on the internal watersheds and closed basins in Turkey. 1. Central Anatolia Watershed includes rivers which have internal drainage and do not reach the seas. 2. Lake Van Watershed. Lake Van, located in eastern Turkey, has its own watershed. 3. Lake Tuz Watershed. Lake Tuz, situated in central Anatolia, has a watershed that includes surrounding areas. 4. Lake Bayzihir Watershed. Lake Bayzihir, located in the Konya region, has its own watershed. 5. Konya Closed Basin encompasses the internal drainage area surrounding the city of Konya, including local rivers and endorheic basins. 6. Afyon Closed Basin represents the internal drainage area around Afyonkarahisar, featuring local rivers and closed basins. 7. Regions of Lake refers to the internal watersheds and surrounding areas of various karstic and tectonic lakes in Turkey and southwest Anatolia. 8. Aras and Kura, Caspian Lake Watershed. The Aras and Kura rivers have their headwaters in Turkey and flow into the Caspian Sea, contributing to the Caspian Lake region. These internal watersheds and closed basins play a crucial role in the regional hydrology, supporting ecosystems, agriculture, and local communities within their respective areas. River regimes refer to the seasonal variations in the discharge, flow, of rivers. Rivers can exhibit different regimes based on the patterns of their water flow throughout the year. Here are the main classifications of river regimes. 1. Regular, equatorial, regime. Characterized by a relatively constant flow throughout the year. Typical in equatorial regions with a consistent climate and steady precipitation. 2. Irregular, tropical, regime. Exhibits significant fluctuations in flow, with distinct wet and dry seasons. Common in tropical regions where precipitation varies seasonally. 3. Sporadic, arid or desert, regime. Periods of flow are separated by extended dry periods. Typical in arid and desert regions with infrequent rainfall. 4. Nival, snowmelt, regime. Dominated by the melting of snow during the spring and early summer. Common in regions with cold winters and significant snow accumulation. 5. Pluvial, monsoonal, regime. Features distinct wet and dry periods influenced by monsoons. Common in areas affected by monsoonal weather patterns. 6. Glacial regime. Flow is influenced by the melting of glaciers. Found in regions with glacier-fed rivers, often in high mountainous areas. 7. Mediterranean regime. Characterized by a pronounced winter flow and reduced summer flow. Typical in regions with a Mediterranean climate, featuring wet winters and dry summers. 8. Mixed, complex, regime. Displays characteristics of more than one regime. Common in areas with diverse climatic influences and multiple water sources. Understanding the river regime of a particular watercourse is crucial for water resource management, ecological assessments, and planning activities that depend on reliable river flow. In Turkey, several rivers are primarily fed by rain, meaning their flow is significantly influenced by rainfall rather than other water sources such as snowmelt or glacial melt. Here are some of the rivers in Turkey that are primarily rain-fed. 1. Yeşilırmak River. Yeşilırmak, also known as the Iris River, is one of the longest rivers in Turkey. It flows through the northern part of the country, draining into the Black Sea. Rainfall is a key factor in its flow. 2. Çılırmak River. Çılırmak, or the Elise River, is another major river in Turkey. It flows through central Anatolia, ultimately reaching the Black Sea. Rainfall contributes significantly to its flow. 3. Sakarya River. Sakarya is one of the major rivers in Turkey, originating in the western part of the country. It flows into the Black Sea, and rainfall is a significant factor in its water levels. 4. Gediz River. Gediz is a river in western Anatolia, flowing into the Aegean Sea. It is primarily rain-fed, and its flow is influenced by the region's rainfall patterns. 5. Büyük Menderes River. Büyük Menderes, also known as the Meander, is a river in western Anatolia, draining into the Aegean Sea. Rainfall is a crucial factor in its hydrology. 6. Göksu River. The Göksu River is in southern Turkey, flowing into the Mediterranean Sea. Rainfall in the region contributes to the river's flow. 7. Yeşilırmak River, Göksu-Irmak. This river in northern Turkey, not to be confused with the Yeşilırmak in the north-central region, is influenced by rainfall and flows into the Black Sea. These rivers play important roles in the hydrology, ecology, and water resource management of the regions they traverse. The amount and distribution of rainfall directly impact their flow patterns. In Turkey, several rivers are primarily fed by the melting of snow and ice, especially in regions with higher elevations and colder climates. Here are some of the rivers in Turkey that are primarily influenced by snow and ice melting. 1. Euphrates River, Fratneri. The Euphrates, one of the major rivers in Turkey, originates from eastern Anatolia. Its flow is significantly influenced by the melting of snow and ice in the high mountainous regions of eastern Turkey. 2. Tigris River, Dikilneri. Similar to the Euphrates, the Tigris River is fed by snow and ice melting in the mountainous areas of eastern Anatolia. 3. Sora River. Sora is a river in northeastern Turkey, known for its steep rapids and scenic landscapes. It is primarily fed by snow and ice melting in the Kakar Mountains. 4. Ceyhan River. The Ceyhan River, located in southern Turkey, is influenced by snow and ice melting in the Taurus Mountains. 5. Murat River. A major tributary of the Euphrates, the Murat River, originates in eastern Anatolia and is fed by snowmelt from the mountainous regions. 6. Aras River. The Aras River, forming part of the Turkey-Armenia border, is sourced from eastern Anatolia, and its flow is influenced by snow and ice melting. 7. Yeşilırmak River, Upper Section. The upper section of the Yeşilırmak River, located in northeastern Turkey, is fed by snow and ice melting in the mountainous areas. 8. Ceyhan River. The Ceyhan River, in southern Turkey, receives water from the melting of snow and ice in the Taurus Mountains. These rivers play crucial roles in the country's water resources, agriculture, and ecosystems, and their flow dynamics are closely tied to seasonal variations in snow and ice cover. Several rivers in Turkey originate from lakes, contributing to the country's diverse hydrological landscape. Here are some examples. 1. Koysacız River, originates from Lake Koysacız in southwestern Turkey. The river flows into the Mediterranean Sea. 2. Beyzihir River, begins at Lake Beyzihir, one of the largest freshwater lakes in Turkey. The river flows westward. 3. Sapanca River, originates from Lake Sapanca, located in the Sakarya province. The river flows northward. 4. Ulyabat River, begins at Lake Ulyabat, also known as Apollyon. The river flows into the Sea of Marmara. 5. Manyas River, originates from Lake Manyas, located in the province of Boxer. The river flows into the Sea of Marmara. 6. Agul River, begins at Lake Agul in central Turkey. The river flows southward. 7. Agurdur River, originates from Lake Agurdur, one of the largest freshwater lakes in Turkey. The river flows southwestward. 8. Sldr River, begins at Lake Sldr in northeastern Turkey. The river flows eastward. These rivers play important roles in the regional ecosystems and contribute to the overall water resource management in their respective areas. The lakes serve as headwaters for these rivers, influencing their flow patterns and hydrological characteristics. Several rivers in Turkey are fed by spring waters, originating from underground springs or aquifers. These rivers often have consistent and reliable flows throughout the year. Here are some examples. 1. Aksu River. A river in the Antalya province, the Aksu River is fed by numerous springs in the Taurus Mountains. 2. Koprase River. Originating in the western Taurus Mountains, the Koprase River is fed by springs and flows into the Mediterranean Sea. 3. Goksu River. The Goksu River in southern Turkey is fed by numerous springs in the Taurus Mountains and flows into the Mediterranean Sea. 4. Alara River. Located in the Antalya province, the Alara River is fed by springs in the Taurus Mountains. 5. Delian River. Flowing through the Muğla province, the Delian River is fed by springs and connects Lake Koysages to the Mediterranean Sea. 6. Koysages River. Originating from the spring-fed Lake Koysages, this river flows into the Mediterranean Sea. 7. Karasu River, Sakarya. The Karasu River in the Sakarya province is fed by springs and flows into the Black Sea. 8. Gediz River, upper section. The upper section of the Gediz River in western Anatolia is fed by springs in the Kütahya province. These rivers play significant roles in sustaining ecosystems, providing water for agriculture, and contributing to the overall hydrology of the regions they traverse. The spring-fed waters ensure a relatively constant and reliable flow, even during dry periods. Mixed regime rivers in Turkey typically exhibit characteristics of both snowmelt-fed and rain-fed rivers. These rivers experience a combination of influences from both snow and ice melting in higher elevations and rainfall in lower elevations. The mixed regime is common in regions with diverse topography and varying climatic conditions. Here are some examples. 1. Sakarya River. The Sakarya River, originating in the Pontic Mountains, has a mixed regime influenced by both snowmelt and rainfall. It flows into the Black Sea. 2. Sora River. Sora, located in northeastern Turkey, is known for its steep rapids. The river has a mixed regime with contributions from snowmelt in the Kakar Mountains and rainfall. 3. Euphrates River, Fratneri. The Euphrates, originating in eastern Anatolia, has a mixed regime influenced by both snowmelt from the high mountainous regions and rainfall. 4. Tigris River, Dikulneri. Similar to the Euphrates, the Tigris River has a mixed regime with contributions from snowmelt in the eastern mountainous areas and rainfall. 5. Murat River. As a major tributary of the Euphrates, the Murat River's flow is influenced by both snowmelt and rainfall. 6. Aras River. The Aras River, forming part of the Turkey-Armenia border, has a mixed regime, with contributions from snowmelt in the mountainous areas and rainfall. These rivers showcase the diverse hydrological conditions in Turkey, where different geographical and climatic features contribute to the mixed regimes observed. The combination of snowmelt and rainfall ensures a more balanced flow throughout the year.